thinking about any questions you've got for our guest. Alyssa's here. Alyssa, if you want to give a wave. And we have Chloe and Phoebe here too. I'm going to kick off the call with just some information about New England Innovation Academy, and then we'll move into our conversation for tonight. I see a few more people popping on, so we'll give it one more minute. All right. Well, I guess we'll go ahead and get started, and we'll let people join as they, just kind of come in as they join us here. And I'm Vicki Grisanti. I am the Marketing and Communications Director here at NEIA. I've got a bunch of my colleagues tonight as well, so I'm excited to see so many friendly faces. So in addition to sort of my marketing and communications hat, I also have a background in competitive robotics programs. And so that's how we kind of pulled this event together tonight. And we're certainly excited to have both our guests kind of speak to robotics and what it's meant to them, and also kind of, excited to bring programs to New England Innovation Academy. So just to kick things off here. If you're familiar with NEIA, we're the kind of school the world needs next. So we're looking for innovators in all shapes and sizes to come and join us. We are the first middle school and high school to prepare innovators to shape the world as they see it. And we really believe that, in this time that we're in right now, education is going to be so important for so many of you. And we've got a unique opportunity to really change the way we do things in the school model. And so tonight we're going to give you a look at what robotics means to us, and then also what our innovation experience is going to look like at school. So at NEIA, our logo is kind of our calling card. It's your pin. And for each of us on the team, we really envision that students are going to come to school and find their passion-driven purpose. It's our goal to help you identify what the things are that you're really excited about doing in your daily life. We're going to help you bring your ideas to impact. So I know I've got a couple of young innovators that are going to be speaking with tonight, and I know firsthand they're full of ideas. So we want to make sure that they have opportunities at school and outside of school to really bring their ideas to life. And then we want to make sure that when you leave school, you are ready for what's next. So you're going to meet Alyssa, who figured all of this out and then some. And we want to make sure that all of our students attending NEIA are going to be just as prepared as she is, or more so, right? So with no further ado, tonight we're going to talk about discovering a passion for robotics. So I'm really excited about this conversation. And first, I want to introduce our guests, the girls who will be speaking with you and interviewing Alyssa tonight. We have Phoebe and Chloe Burke on the line. Can you guys unmute and just say hi to everyone?
Hello.
Hi.
All right. So Phoebe and Chloe, I'll speak a little bit for you. They were both on VEX IQ challenge teams, and they were part of a program that I was involved with. So it's really exciting to have them and have them get a chance to talk to Alyssa tonight. On the left side of the screen, you'll see a picture, like a giant auditorium behind them. They attended the VEX Worlds, we called it. It's a competition that draws in, about 1,000 of the best teams from around the world. And when I say around the world, they drew in about 60 different countries. So the girls had an opportunity to attend that event. And most recently, they won a design award at one of their competitions. That's their middle photo there. And then on the far right, they had a chance to attend an event at WPI. So some of the folks in the photo behind them were the volunteer judges and adults kind of in the room guiding them and helping, ask questions about their design notebook and their robot and kind of learn more about them. So I think, these opportunities are really unique, and we want to make sure that kids have more of them. So thanks, Chloe and Phoebe, for joining us. And they're going to be asking Alyssa some questions really quick coming up here. And then next up, we have Alyssa. So feel free, Alyssa, to introduce yourself to everyone and tell them your story, I guess, or your Yeah.
Hi, everyone. Yeah, my name is Alyssa, as has been mentioned. I grew up in San Diego, California, and I got into robotics out there. And then I went to school for robotics, and now I work full time as a process engineer at Amazon Robotics. So definitely found my niche, and I've continued on with that. So I'm excited to be here. And I also went to a school that was a lot like NEIA in San Diego, in the sense that it was really unique and it focused on giving students a lot of opportunities to find passion. So I'm really excited about the school and what you guys are doing, and I'm excited to be here and talk about robotics.
Great, thank you. So now, Phoebe, Chloe, I don't know who's starting, but I know you've got some questions prepared for Alyssa. So do you want to go ahead and kick it off and ask her some of your questions?
Okay. What types of activities were you involved in growing up?
So before I got into robotics, I was really involved in dance and in gymnastics, and I rode horses for a while. I did a few years of softball, things like that, bounced around a bit. And then I really honed in on dance and theater sometime in middle school. And I stuck with those actually all the way through high school as well. So yeah, that's what I was involved in outside of robotics. It was fun.
Um, how old were you when you got involved in robotics and technology, and what inspired you to start?
Fun story. I was 13 and I had just gotten into high school. I was a freshman and I was wandering around at the clubs fair at my high school. And there was a group of upperclassmen that seemed very, very cool hanging out at the robotics table. And they had this machine that was throwing these like foam balls that were painted to look like basketballs. I didn't think that it looked like a robot at all because my only experience with robotics at that point was what I had seen in movies. And I walked right up and I struck up a conversation with these guys because they were all guys. And I think I said something along the lines of, that doesn't look like a robot. And they looked at me like I was insane. And one of them said, well, you should join the robotics team and learn that it is. And I said, well, not really. I'm not really interested in robotics. I don't even like math. I'm not good at math. And he said, well, we need a lot of help with things like marketing and business and outreach and fundraising. And you seem like you would be really good at that. So you should still join. And he was very, very cool, as were all of them. And I was a freshman and I didn't know anyone. And so I decided to join. And at first, I was just helping out with marketing and research and outreach events like the one that you're seeing in that photo. But I really quickly moved into electronics and machining and actual engineering work, and it kind of stuck.
What was the name of your first robot?
The name of my first robot was the one that I helped work on my freshman year of high school. My high school robotics team was called the We Are Robot Lords, Warlords for short. I didn't name the team. I was roped into it, but we had a tradition of naming all of our robots after different warriors and military heroes in history. So our robot that year was named after Sun Tzu. He was a Chinese military strategist, and he was born, I think, in about like 500 BC, maybe. So a really, really long time ago, but he wrote a book called The Art of War. And we had a quote of his that we etched into some of the metal underneath our electronics belly pan that read, the supreme art of war is to subdue the enemy without fighting. And we thought that that clicked really well with the robot that we designed that year because the game that we were designing our robot, we were part of this competition robotics program. So they would give us a game every year and we would design and build a robot to compete in that game against a lot of other teams all over the world. And the game that year was this kind of ultimate Frisbee situation, but you could only hold 4 Frisbees at a time. So you would have to retrieve your Frisbees from one side of the field and then drive around all of the competition to the other side of the field and shoot the Frisbees into these goals that were pretty high off the ground. And that's how most teams played the game. And, you know, you had to run into defense and you were tripping over other Frisbees, driving over other Frisbees. There were these big pyramids in the middle of the field that could kind of slow you down. And we decided that we wanted to focus all of our energy into building a Frisbee shooter that could shoot the Frisbees from the other side of the field and just not interact with the competition at all. We would just go plant ourselves where we retrieve our Frisbees, and we would design a shooter that was capable of shooting it. Oh gosh, I can't even remember how far it was, but it was far. It was over everything. And that's what we did. We designed a robot that could subdue the enemy without even fighting. We just sat over in the corner and shot our Frisbees all the way across the field the entire game. So that was a really long-winded answer to what could have been a 2-word answer. But my first robot was named Sun Tzu.
What challenges did you face to be where you are now? And what were some of the ways you overcame those challenges?
Oh gosh. Well, I did mention earlier on that when I first got into robotics, I thought I was bad at math. I had a couple of bad math teachers in middle school, coupled with, you know, the way that I was being taught math. I don't even know what it was, but for whatever reason, I had this ridiculous notion in the back of my head that I was bad at math. And it took me a few years to get past that. And then subsequently, it took me a few years to kind of strengthen my math fundamentals before I got into real engineering, because I had kind of breezed past, you know, all of those really important algebra classes in middle school because I thought I didn't like it and I wasn't good at it. So that was a really big challenge of mine academically. And I just got through that by lots of extra studying and lots of really great friends and lots of really great teachers and professors and some extra time. So that was really, really good. And then something really amazing that's happening nowadays is that kids your age are getting into robotics a lot earlier. But when I was 14 or so, robotics was a little bit more niche and a little bit less common for people to participate in. And it was really less common for girls to participate in, which was terrible. But because of that, when I first joined my robotics team, I was one of 4 girls on our team of 20 something. And that ratio never got better. The team grew a lot, but the ratio of men to women didn't get any better. And then I got to college, and my school had an 80-20 male to female ratio in the engineering department, which was pretty messy. And now, as a full-time engineer, I'm the only woman on my team. And that leads to a lot of really terrible imposter syndrome, which just means, do I actually deserve to be here? Do I belong here? Should I be here? Am I doing the right thing with my life? Like, is my entire career off track right now? So that's been a really big challenge through the years. And that one, you just kind of, I will not tell you that I have fully solved it, but I will tell you that I have slowly gotten better at telling myself all of the time, you do deserve to be here. It does make sense that you're here. I have a really great support system, and a lot of the mentors that I built up in my time in high school robotics and in college, they still are really great support systems to this day. So a lot of people that have watched me grow and have supported me and that I can reach out to whenever I'm feeling out of sorts, if that makes any sense.
What processes did you go through using robotics as a part of the engineering team? How different is it from your competition experience?
There's a lot of very real similarities, which is why I think that competition robotics is so great for kids. You know, you're still working in a really fast pace. You're using a lot of the same fundamentals in physics and in math. And a lot of those fundamentals you can carry with you throughout your entire career. You get a lot of experience working with the same kinds of people that you'll find in engineering fields as an adult. That being said, I like to call competition robotics Band-Aid engineering, in that you build it really, really fast, and you don't necessarily always do the math, and it sometimes works and it sometimes doesn't. And when it doesn't, you don't really solve the root problem. You find some duct tape and you make it work for the next match, which is a really great skill to know how to do in life and in robotics and in a lot of different things, but in more professional process engineering kind of environments, when you have standards and contracts, and safety is a huge player. It's a lot more important to actually do the math, to actually do the science, to take your time with it and make sure that you're checking all of those boxes and working with other people and making sure that they're checking all of their boxes as well. Redundancy is a really big word in engineering, in real world engineering, as in, you want to make sure that there's not one sensor, but there's three that are all reading the same thing in three different ways to make sure that you're getting the right values and the right data. And that's a really big deal. Whereas in competition robotics, you got your one sensor, and if it messes up, then you lose that match, and it's okay. You move on to the next one. So yeah, a lot of same fundamentals, different implementation.
What are some of the most exciting and most difficult parts of working on an engineering team?
I had a college professor that I very arrogantly thought that I didn't like when I first met her, because she once told me, while I was struggling through a laboratory experiment, engineering is about pain. And I looked at her and I said, that's particularly rude. Like, you're watching me really struggle right now, and I'm having a really hard time, and you just don't care. Like, that's very cold and very mean of you. And I said something much nicer than that to her and kind of tried to talk through those feelings. And she looked at me and she said, Alyssa, no, I'm serious. Like, all of the best engineering is about the pain. If it's easy, then it's not going to be rewarding when you finish it. So I always like to say that, the most difficult parts of robotics and working on an engineering team are actually always the most exciting ones, because they lead to the best stories, they lead to the best learning experiences, and they do lead to the best designs and the best robots and the best everything else. So I will start with that. That being said, some of the biggest challenges that I've worked on, I guess I'll give you one technical and one non-technical. So for the technical one, actually the photo that Vicky has up right now is a photo from my college competition robotics team, which was an underwater robotics project. So we were designing basically a submarine that would swim to the bottom of an Olympic-sized swimming pool and go through a series of challenges and either do well, not do well, and get points accordingly. And we would have 15 minutes to do all of these crazy things. And then we would get scored against other teams that were also trying to do the same crazy things at the bottom of an Olympic-sized swimming pool. And the team that I was on when I first started, there were 6 of us. And we had never qualified for the competition. And our school gave us an attic, which is also in that photo. And it's pretty dingy, but it's home. And we had no idea what we were doing, and we were attempting to do very real waterproofing technology. We were trying to figure out how to waterproof electronics to pretty real pressures. And we ordered a few pieces from an underwater robotics website that claimed to be set for a certain PSI, and then we did a lot of our own work as well. And we very naively thought that the robot would be waterproof our first time putting it at the bottom of a pool. Someone had the good sense to say, let's test it out without the electronics in the capsule, right? Let's put the capsule to the bottom of the pool without all of our expensive custom electronics in it, see if it's waterproof, and then bring it back up. And I may or may not have told them, well, that's a silly idea. Of course it's going to be waterproof. Sent it to the bottom of a pool, came back up after 20 minutes. It had about 3 cups of water in it. And that began about a 2-month long process of debugging where these leaks were coming from. And, we tested everything, and then we got it down. It took months, and we got it down to like 3 drops of water. Like 3 drops were left, and we could see them in the bottom of this little dome, and we were so confused. We had no idea where these 3 drops were coming from. We had tested everything. We had fixed the really big leaks. And then one night, someone said, have we actually tested all of the components that we ordered from the companies? And we hadn't tested these components that were sent to us and made by professionals and that we had assumed would work according to their standards and the standards that they had listed on their website. So we isolated that variable, and we realized that it was in fact the things that we had ordered and the things that we hadn't actually had any control over. And we added a ton of extra waterproof epoxy to it, and it was then waterproof. So that was definitely one of the longest term technical challenges, most frustrating technical challenges I've ever encountered. And then non-technical, working in a team of people is difficult in any industry, especially in an industry where people pride themselves on their lack of communication skills. So that's definitely just been a challenge, but also a really fun one to sort out, like how to best work with people, how to best get everyone's ideas put in the center of a room to get a project moving forward. So that's something I'm going to continue working on for probably the rest of my career, but it's fun. Anything else?
What advice would you give students today who have an interest in robots?
Advice. If you have an interest in robotics, then definitely enjoy the competitions, because they're what give you passion, and they're what give you excitement, and they're what give you competition. Whether it's a competition or a project or an extracurricular activity, anything that has to do with that kind of stuff, like enjoy it and have so much fun doing it. But don't neglect your fundamentals, because like I said, all of that fun stuff is really great and really important for so many reasons. But it's Band-Aid engineering, and it tends to neglect to take into consideration the really important fundamentals that you will need if you actually are thinking about pursuing it as a career. So make sure that you're, taking your math classes and studying up.
Oops. That is great. I think that was their last question, right? Phoebe, Chloe, where we got through those. Did anything else pop up for you guys as Alyssa was explaining, or giving you her answers and her thoughts? There was so much in there. I took away a lot from that conversation. I'm curious if, and I saw Phoebe's eyes light up when you said, enjoy the competition experience, because I think that's where you make all those friendships and certainly do have a lot of fun. But
So fun. I miss it.
Yeah. Me too. It's been a while since we've been in person to compete as teams. So it's certainly been a different year. But yeah, so girls, any other questions from your end? We're also going to open it up to anybody on the call. If you want to add questions to the chat, we're going to let Alyssa answer a few of those. And then as we wrap that up, I have a couple more slides to show you, but I see one from, so Phoebe, Chloe, anything else from your end that Alyssa mentioned that you might want to ask about? No?
I don't think so.
No? Well, thank you both for participating. I really appreciate it. That was great. So in the chat, I see one question here about what are some of the skills learned by doing robotics that have transferred to other areas of your life?
Oh gosh, so many. Process engineering, I like to say, is really important in real life situations as well. I had a robotics mentor named Ken Collins in high school, and he did a lot of carbon fiber work with me. And if you're familiar with carbon fiber work, it is process engineering at its finest. It is one of those things that you spend like 6 hours doing all of the prep work and planning it, and then you spend 10 minutes actually laying out the carbon. And if you don't spend the time doing all of that prep work, your actual work is going to turn out terribly. And I used to just rush right into the epoxy every single time. I would just lather in epoxy without thinking through, how are we going to let this set? How is this going to set over time? All of those really big, important questions. And he used to look at me and say, Alyssa, slow down, do it correctly, and make a plan. If you don't make a plan, then you're not actually engineering, you're just duct taping. And that has been hugely important in my everyday life as well, because I tend to just charge right into things, all excited, fired up right off the bat. And slowing down, taking the time to think things through, make a plan, all that good stuff. That's really important. And then also just all of those interpersonal things, learning how to communicate with people is really important. And I feel like I learned most of that through robotics.
Yeah, I totally agree with you there. I mean, I've seen kids, just their entire demeanor kind of changes when they are, go from not being on a team to being on a team. You've got to communicate with your teammates. You have to talk to adults. You're talking to judges and people that you've never met before. It's really kind of that part of, I think, the robotics competitive experience is really transformative too. I know in the comments you alluded to it, but we didn't ask a question around it. I'm just curious, were there mentors along the way, like people who encouraged your journey or have like kept you, as you talk through the imposter syndrome experience, you mentioned like reaching out to those friends. So I'm just curious how mentors have maybe impacted your career so far too.
Definitely. So in most of these competition robotics programs, they do call the people that are helping students work on these robots mentors, which is great because it just instills that concept of mentorship being really important at a really young age. And I, picked up a lot of those mentors through those programs really early on, and they've stuck with me, and I'm so thankful for that. And it's always a treat when I get to see them and have good conversation with them, and they always check up on me. And professionally, it's so helpful just to have people, like when you're feeling like you're in a tough spot and you're not sure which direction to go towards. Obviously, like friends are really great and family is really, really great, but sometimes you really need people that are in your field and in your career and that have experience doing what you're trying to do. And being able to go to them and ask those questions is really, really important because they've been through it. Yeah, I have a couple of really great mentors in San Diego that I really love getting to see. Whenever I get to sit down with them, it's a treat, and I feel excited and passionate and ready to move forward with whatever it is that I'm planning on doing next. And then at work, I've got a couple of really great ones as well, which is amazing. So, yeah.
Oh, that's great. That's great. I know some of the photos we showed, and feel free, if anybody does have a question, you can unmute and ask directly too. But I was going to say some of the photos we showed were of you where I imagine you were volunteering either at the school you attended or someplace else maybe, right? I know volunteering is a big part of the experience too. And at NEIA, we're looking at service learning opportunities for kids. So I wonder if you could talk to us a little bit about how that part of your experience with robotics and how that influenced your...
Well, you just, from a really young age, you see people giving so much of themselves back to students. And I think that volunteering, especially volunteering in something that you're passionate about, like any kind of volunteer work is obviously amazing, but when you're volunteering in a field that you're passionate about, doing something that you're passionate about as well, it's kind of doubly amazing because you get that really great feeling of I'm doing something great for kids or for the community or for whoever it is, and you're also doing that great thing. And I think that kids get a lot out of it, people get a lot out of it, as well as yourself. It's how you and I met. You also get to meet lots and lots of amazing people that are also interested and passionate about the same things that you are. So yeah, that's been hugely monumental in my life. And I feel like most of my really close friends I've met through that. So
yeah, absolutely. Yeah. One question in the chat here. So if you're taking ideas from blueprints to reality, what does robotics mean to you?
oh gosh.
Yes. So maybe if, I think of Phoebe and Chloe, when I saw them, they'd work on their design notebook, and another team member of theirs as well. And a lot of times, in competition robotics, you spend a lot of time drawing out. And we're actually going to talk about this in a minute too, is what we will do at NEIA, but kind of drawing out your thoughts before you make it into like a physical object, right? So I guess what that experience is like for you.
Yeah, it goes back to that concept of, slow down and take your time planning things. Because if you do it correctly, if you do your blueprints correctly, and if you do your design work correctly, then the actual building should be pretty simple. And then when you get to your actual career, I know at Amazon Robotics, we don't really build all too much ourselves. We spend enormous amounts of time doing design and planning, and then we send off very, very refined designs and blueprints to contractors that we work with that help us and do supply chain engineering with us. So I think that's huge in most industries. I would imagine. I've only ever worked in this one, but
So in your example, sorry to interrupt, in your example with Amazon, so in that process, I guess you're sending these blueprints off. Do you get to see the finished product at some point?
Yeah, absolutely.
And that must be like
always really, really rewarding. Yeah. So, companies tend to specialize in one thing. So there's companies that are really, really great at plastics, and there's companies that are really, really great at metals, and there's companies that specialize in 3D printing. And you want to find the best, right? You want to find the best of the best company to work on each one of these things. And no one company can do all of it. So robotics and engineering companies tend to spend a lot of time doing the design work, and then have an entire team that spends a lot of time doing research on the right companies for the right parts. And then we order all of those parts, and then they come back to us, and we get to assemble them and see the finished product, which is always extraordinarily rewarding. So
that's great. I'm curious too. We've talked a lot, I know, among my robotics teams, and even now moving into NEIA, and certainly within the VEX experience, right, about failure and how important it is to learn to move past failure, or kind of enjoy the experience of failing and failing often. Do you have any advice for kids who, either struggle with that, or I think it's tough as a young person to really embrace that experience, and frankly, even as an adult, right? Yeah.
Oh yeah. The first time I remember like truly like life-altering failing was my junior year of high school. We failed. We lost a robotics competition. We should have won. We didn't make it to championships for the first time in my robotics career. And I remember it was a competition over Easter weekend. And the competition ended on Saturday night, and then Easter Sunday, my parents let me out of all of the Easter activities because I was just a wreck. I locked myself in my bedroom. We had a ton of family friends over for like an Easter egg hunt. There were little kids running around, and I was just, oh my God, like the worst feeling I've ever experienced in my entire life. And then it happened again in college. The same kind of devastating loss that just sat me right down for, I think, about a week. I just kind of retreated into myself. But you know what? If you have the right people around you, and you should always make sure that you try to, they pull you right out of it, and you come out far more impassioned to not let it happen again. And it does, but hopefully not for a while. And you do learn from those mistakes if you're smart. So I don't ever wish to revisit those moments in my life. That being said, they definitely led to some of the best seasons I've ever had.
Yeah, that's great. We've got one more question here in the chat. Could you please discuss the variety of roles on a robotics team, and how those roles allow for different skill sets and people to participate in the common cause?
Yeah. So I feel like I'm a really great example of that, because pre-robotics, I think I probably would have gone into journalism. I love writing. I love communicating. I love talking, obviously. And I think I would have really liked that. And that's a hugely important skill in the robotics field. And that's how I got into robotics. But, there's also kids that are really good at electronics, and really good at building, and really good at coding, and all of those things. So yeah, there's so many different roles to play. I always said that there is something for everyone on a robotics team, because they're run like small businesses, and there's something for everyone in a business. So regardless of what you think you're good at, join, try what you think you're good at, but also try things that you think you might not be good at, because it's all leading towards that common cause. And you might learn that you're better at something than you thought.
Yeah, absolutely. I know we spoke to Chloe and Phoebe ahead of the call, and I was super impressed. I know they love to build and drive and, just have all these different aspects of the team. I think they said everybody on their team participates in the design notebook. So that's when you're actually writing out the things that you want your robot to do or drawing it. So I think Alyssa's right. There's so many different roles for people to play on a team like this, and just trying it is that first step. So for sure. So any other questions? I can't think of any, but oh, we have a raised hand. Alexander, go ahead. What's your question?
Hi, I'm Alexander, and I just have a question about going back to that idea of blueprints. So, typically when you have like say a purpose for a robot, like it has to go this far of a distance, and you're coming up with ideas, but you get that type of version of like writer's block, but like robotics, and you can't come up with ideas. How do you manage that? How do you think of innovative ways, or just try to think of ideas and then actually get them onto building it?
Okay.
So that very cool boy that I was talking about early on that got me onto my robotics team, he was a junior when I was a freshman. So he was very, very ahead of me. I looked up to him probably a bit too much. But he once told me when I was going through kind of that thought process my first year, he told me, I think it's a Picasso quote. I'm not sure. I should look it up. But it is true. All of the best engineering and all of the best designs and all of the best artists, they steal, right? You're building upon what has been done before. You're never starting from scratch. All of your knowledge, all of your ideas, all of your designs, they are based on a wealth of knowledge that has been put forth ahead of you, right? Like you're never actually starting from scratch. So if you're ever having trouble coming up with something on your own, of course you are. Like you just need to spend a lot more time researching, right? Find a lot of ways that it has been done. Find a lot of ways that something similar has been done. And then take the best parts of each design and kind of try them out and mesh them and think, well, maybe I can change this one variable. And that'll push it over the edge and make it a little bit better, right? Like you're never starting from scratch. You're never trying to reinvent the wheel. What you're trying to do is make a better wheel, right? The tiniest bit better. So take a design that you can find and try changing small variables, would be my advice. Research is always what I retreat back into when I'm feeling a lot of writer's block. I guess I'll call it design block. Or blueprint block, right? Just spend a lot of time researching and talking to people that are in the field. I think that for whatever reason, I think that we spend a lot of time talking about plagiarism in school, which is really important and a really good thing, right? Obviously, you never actually want to be copying someone else's work, especially in writing assignments and things like that. And they talk about it from a really early age. But I think that because of that, a lot of kids are nervous to take other designs when they get into these more technical fields and then start editing other people's designs, which is not plagiarism, it's invention. And that would be my advice for trying to push forward with some of those. I don't really know how to move forward with this problem, is just research.
Yeah, that's a great point. People have warmed up. We've got a few more questions for you. So I'm going to ask those and then I'll move to close us out just to keep us on time. We were going to shoot to end by 8. So let's see, what do you suggest for kids that struggle to come up with designs? And I think you just touched on that. Yeah.
Research. Just
and we always tell, my teams, and I'm sure Phoebe and Chloe have experienced this too. If you are at a competition and you see somebody else's robot doing something and you say to yourself, I want to be able to do what that robot can do. How do I do that? And then you do the research and you kind of figure it out. I've seen so many of our teams have that experience. And then the beauty of it is you're learning how to do a new task that you didn't even know how to do before. So yeah, it's definitely a cool thing to.
Especially in competition robotics, like most of the research is just how did another team do this like 10 years ago or 5 years ago? And all of the matches and stuff are online, right? You just look at it and reverse design it and reverse engineer it and maybe even shoot an email to the person that designed it. You know, that works in industry and in competition robotics, just shooting an email and seeing what people say. Most people are really willing to teach because they're passionate about what they did. And they're excited about passing forward that knowledge.
And then we've got somebody on the call who's a 5th grader and really likes technology too. This person said, when I grow up, I want to work for Microsoft or Apple. Do you have any advice for me? By the way, I know you can speak Mandarin too. Awesome.
Rough Mandarin, but thank you. Oh gosh, when you grow up, you want to work for Microsoft or Apple. Well, I work for Amazon, so I feel like it's kind of in that realm, so I can kind of speak to it. It's really just about getting all of the experience you possibly can, right? Bolstering your tool belt and your knowledge base to the point where you feel really prepared to work on those really hard problems that those companies are solving. So just be involved in as many things as possible and learn as much as you can and be as passionate as you can. That's really what all of these companies, whether it's Microsoft, Apple, Amazon, a startup, mid-sized companies, all that they're really looking for is passion and an excitement to learn and an excitement to do things. So find something. Technology is a big field. There's a lot of different aspects of technology, but find something within technology that really gets you excited, because that's what people respond to. Not, you know, an A, like they do care about your grades, but they care a lot less about a list of achievements than they do about your excitement, your obvious excitement about solving a problem or working on something. So that would be my advice. Find something you're excited about. And then also just meet people. Try to meet as many people as you can, because you never know who has a friend that works at one of those companies and might just want to have a conversation with you. That's how I got my job. I was at a Women in Science conference in Boston, and there was a girl that had an Amazon Robotics mug, and I had no idea that there was such thing of an Amazon Robotics. I didn't know what Amazon Robotics was. And I walked up to her and I said, "Hi, I'm super interested in robotics. Amazon has a robotics division?" And she said, "Yeah, let me tell you about it." And we got to chatting and we had this amazing conversation. And then she recommended me for a job. And I've been working there for 3 years now. So just, you know, find something you're passionate about and then try to meet as many people as you can.
That's great advice. And then last question for the night, and then I'll flip it over to a couple of slides about NEIA. Let's see, oops. What do you do at Amazon Robotics, and what sorts of skills do you find important there?
I am a process engineer at Amazon Robotics. So I work on, I work with the hardware engineering team and the manufacturing engineering team on finding common solutions to, I work on finding common solutions to the designs that they are working on together. So I basically edit the hardware team's designs to make them manufacturable. And then I work with the manufacturing engineering team to make sure that they're up to code with what the design engineers had intended according to their mathematics. So a lot of communication, a lot of engineering, kind of all the stuff that I've touched on.
Yeah.
And those are the skills that are important there, right? Communication and engineering, and being able to work on a cross-disciplinary team.
Absolutely. Thank you. That was such a great event, such a great chat. So wonderful to hear all of your experience and have a chance for Phoebe and Chloe to chime in with their questions. I'm going to share my screen real quick again and just walk you through what Alyssa's doing in her job and how that might translate to what you could do at New England Innovation Academy. So at the school, we intend to have an innovation studio, and this would really give kids an opportunity to get that hands-on experience. I know some of you have seen us talk about you know, we mentioned at the start of the call, bringing ideas to impact, but really our idea is centered around human-centered design. And what do we mean by that? Well, we want to make sure that all of the things we're designing, right? So whether it's the products around you right now in the room that you're in, the house that you live in, the school that you attend, like all of those things were designed by someone. And when you're designing at our school, we want to make sure that you're thinking about the person you're designing for. So you're not just putting ideas out there, but you're actually giving some thought to who needs this product and what do they need to use it for, and how can I talk to them to understand their needs. So as Alyssa was saying, communication is going to be super important. Working on interdisciplinary teams, so with people who aren't like you but think differently, and understanding like what they need out of the thing that you're going to create, is going to be central to the things that we're going to do in Innovation Studio. And what's really fun about it is on this next slide, you're going to get to see, I know some of you are already familiar with this and you've heard a little bit about what we're going to do, but essentially the Innovation Studio experience would be like right in the dead center of all of your other coursework. And so your experience in arts and science and math and well-being and humanities, all of those things that you're learning in your other classes would feed into your Innovation Studio experience. And that's where you get to do hands-on kind of project-based activities and build things. So you'd create those blueprints that we were talking about, right? Or you design your idea for what the solution could be, and then you get to build it in class. So we call that kind of rapid prototyping. And I'm sure Alyssa knows that term. And that's probably your duct tape experience, right? Where you're just like quickly putting stuff together. Doesn't really matter what it looks like or how beautiful it is, but let's see if we can get the idea into a 3D shape that other people can understand, so you can show it to them and explain your idea, right? And then as you move forward in that process, you're going to start to refine it and make tweaks and changes and make it the thing that actually works and does the job that you have in mind and maybe helps somebody in their daily life, right? So that's really what our school and our experience is all about. And we are still enrolling for grades 6 to 12. And I want to quickly introduce my colleagues, Kevin Ramos-Glue, Dean of Enrollment, and Bryn Stevens is also on the call. If you guys both want to say hello and introduce yourselves.
Hi, everyone. I just want to tell you, I think it's awesome that you all came to this, because you think about it, you are on Zoom probably a lot during the day, but you came because you're inspired by this. And I'd say my biggest comment that ties into it is, if you noticed in all those photos that Alyssa had this joie de vivre and joy on her face as she was doing. And I'm sure, who knows, 60%, 20% of the time she was failing forward. And I think she had this joy and she brought it to this. And I think that's so emblematic. And I'm honored that she thinks that her education was similar to this, because I think it's very reflective of it. So hopefully if you liked what you saw and you're just even curious, find us. I'm Kevin, and Bryn can say hi next. So great job being you all and dialing into this, and keep a look on our face. We'd be happy to chat with you anytime by email or phone.
Yeah, so I'm Bryn, I'm the admissions coordinator. So after you talk to Kevin, I'm the one that sends you the link to apply to the school essentially. And I'm here to answer any questions you may have. And we're just happy to help you.
Yeah. All right. Thank you both. So one last big round of applause and thanks to Alyssa. I really appreciate your joining us tonight and sharing your experience. And certainly to Phoebe and Chloe, you guys are amazing. And I'm looking forward to seeing you back at a competition soon, right near our, at a local school or one of our fun events nearby. So thanks everyone for coming. Please feel free to reach out, ask us questions, let me know how we can help you, and have a great night. Take care.
Thank you for having me, everyone.
Yeah.
Bye.
Thank you.
Thank you.
Thank you.